Here is the next video on the subject of PySpark, and here we are going to deal with groupings and aggregations. This is a new data set I am dealing with. This has a fields, and this is a sampled data. Two last fields were calculated. This was invoice number as string, and this is invoice number as number, and we have year, month substring. Otherwise, these are orders with this. This is stock code. This is invoice. Basically, there are invoice lines in the same file. Nothing is separated into invoice details. There are invoice details here, product name, quantity of products, invoice date, unit price, customer ID, country, invoice number, and year, month. Now let's proceed with the exercises. Okay, calculate count and count distinct. This is a bit more sensible. We are calculating count of rows and distinct orders per stock code. Well, the grouping is stock code, basically the product or a certain item or certain good, certain kind of goods, and we do count, and we do count distinct, and I also added min max of description to see if there is any difference. So basically we have stock code, count distinct. There are less count distincts than counts, and sometimes the products are different in names despite the same stock code. Normally they should be the same, min and max description, but sometimes there are some discrepancies. Okay, the grouping is calculated in two ways, by Spark syntax and by SQL syntax, Spark SQL. Sum total quality per stock code. Sum total quantity per stock code. Simple demonstration of sum. We are calculating the quantity of products sold in total. So this is the total number of stock codes. So this is total number of quantity products sold per stock code. Okay. Next thing, some distinct unit price values. So it's only mentioned here. We should find a unique number of unit prices. So we count distinct unit prices, and this is a distinct unit price. This is a stock code, and these are the unique prices that existed per this stock code. Average, mean, max quantity per year, month. So we calculate, we take certain month within year, and we calculate average, minimum, and maximum quantity of products. Some products, strangely enough, have negative numbers. This probably means they are returned. But otherwise, this is min and max. Average unit price per country. So we calculating the average unit price in certain countries. Here we see various countries and average prices of all products in these countries. Okay, min max invoice date per stock code. So here we can see the minimum and maximum invoice date, which means the earliest and the latest date the product was sold. and this is the result. Standard deviation of quantity per stock code, StdDev, we have seen it in another video. StdDev sample is the same, StdDev pop, and this is the difference between StdDev samp and StdDev pop. There is some difference between the two. A variance of quantity per stock code, again this grouped by stock code, various aggregation functions, and StdDev quantity, StdDev sum quantity are the same, and StdDev pop quantity, and there is a difference between these two. Okay, Skewness and Kurtosis, simply calculated. Covariance between quantity and unit price, covariance sample, covar pop. I calculated it both ways, and both ways it's the same. It doesn't matter, the order of the field is not important. Correlation between the two, also the order of fields is not important, the result is the same. Monthly total quantity per stock code. Basically sum quantity, aggregation by two fields. Here we have stock year and month total quantity for this field. Count number of months each stock code appears in count distance. So basically we need to count the unique number of months each stock code was sold. So some has 13 months, which means every month in the data set. Some numbers are less, and means that the product was not being sold all the months. Find products with highest and lowest unit price, unit min max, no, min and max, and then we these are min and max prices. We need to find products. So we first calculate min and max prices. Here they are, the min and max price. Then we find out products with these prices. So this is a product with maximum price. This is a product with the minimum price. However, it's negative. So it was returned. Here I combined them into one result set. Basically, I applied union between the two. Okay, next thing. Compute total revenue per stock code. Revenue is quantity multiplied by unit price. So we first calculate this field. We add calculate the field to the dataset, and then we group by stock code. Then we sum revenue. The revenue is summed within this grouping. So here is the result, stock code and total revenue per stock code. StdDev of revenue per stock code, nothing special, field of revenue, group by stock code, StdDev sum calculated. Okay, next thing is average quantity per country and per product. Use average. So we calculate average within two fields, country and stock code. And this is average quantity per these countries and these stock codes. So what is the average sale of this stock code in this country? By within the total time. Variance of invoice known number per year month. How much the invoice number varies within 1 month. So variance and so on. This is how it goes, smaller and bigger within each individual month. correlation, invoice known number versus quantity. So the correlation between invoice number and quantity, not a strange thing, but here is how we calculate it. Covariance, quantity versus revenue, global group by, and covariance between the two. The next video will be about special functions like last and conditional and so on.